Hello, let's look into today's Leetcode problem. Find score of an array after marking all elements. So in this question, you are given with an integer array nums and you are allowed to do certain operation in that integer array. And the operation goes like this. Choose the smallest integer of an array that is not marked. And if you find any conflict, if you find two index that has the same value, that is both of them are smallest, then you should choose the uh, index that has lesser number in it, like shortest smallest index basically. Then what you do is initially there will be a variable called score and its value is set to 0, and every time you choose a value in the array, right, then you should add that value in the score. That is step 2. Then after adding the value in the variable score, what you have to do is uh, you should mark that chosen element, or in that index you should say that this element is visited. It's basically a proof that okay, this element is visited. And the other thing is, it's you should not only mark the selected index, but you should also mark the adjacent elements also. So let's say if you have chosen this index 3 here, then in that case 1 should be marked as well as 4 should also be marked here. So because 3's neighbors are 1 and 4, right? In the case of extremities, let's say if we are currently in the first element, then in that case you can mark the writer index. There is no left index, so there's no point in marking it right now. Similarly, it goes for the this case also. And you should be repeating this operation until all the elements in the array are marked, and in the end what you do is simply return the result, that is our scores. Let's try looking into one of the examples and quickly understand on what needs to be done. Okay, so in this example, the first step that you have to do is choose the smallest index 1. So I will start with the score, um, initialize score to 0. I chose the index that has smallest value. I increment the value of score to 1. I set this value. I set the neighbor value also. I will mark them as visited. Then what I do is I uh, do the next step. That is basically go to the index that is not visited and at the same time smallest. So, so the smallest unvisited index is this one. So we will be adding 2 to the score, and we will be marking the neighboring index also. And in the next step, you are left with only one index that is unmarked. So you will simply add that, and already we have 3 and 5 to be marked, so nothing needs to be done there. And in the end, we can see that all of the elements in the integer array is marked, so you simply return the answer, which is 3 plus 4, 7, and that's what they do here. So the question seems pretty straightforward to me. So every time what you need to do is find the smallest index that is not marked, uh, and after that you add that index value in score and mark the neighbors as well. That is an additional thing that you do, and you continue the process. Okay, so in this question you are asked to find the smallest element every time, right? In after each operation you are asked to find the smallest unmarked index. So this actually gives us a clue on like it's basically like telling us to use heap here, because in heap also in an iteration when you do iteration one by one, then if you want to find the smallest index one by one, then heap will be an answer. So heap or priority queue. So we can use a min heap here. So in min heap, what happens is, let's say we have our elements stored in the heap, which is like this. And every time you query for an element, right, in min heap, the minimum element will be queried first. So one will be popped out for the first time. What we can do is, let me write it out one more time. So what we can do is simply, select this index, mark it, mark the next neighbors, and for the next time, two will be popped out. And like the question they said, if there is conflict between two indices, then you choose the smallest index. So here, um, let's say here, after you push all the elements into heap, right, the order gets jumbled. So in that scenario, a possible solution that you should come up with is uh, add indices also. So by indices, what I mean is this part. So you have an array or intermediary array or something like that, which stores the index of that position as well, like this: 3, 2, then element 4, which is present in third index, element 5, which is present in fourth index, and element 6, which is present in fifth index. And your min heap should first consider the first value present in that pair to compare and make a decision. And in case of conflicts, then you compare the index. So that's how your minimum heap should work here. So let me redraw this again. So our min heap will be looking like this. We will insert all possible elements in the min heap: 4, 3, 5, 4, and 2, 5. So for the first time, this index will get popped. You you can, you know, store the visited index in another data structure. We can take a hash map, or in C++, we can use unordered set. We will add that index in this unordered set, saying that, yeah, it is visited. So index 1 is visited for now. You pop it out, and at the same time, you should also mark the neighbors, right? So what I'll do is I will mark the neighbors as well. So my neighbors are basically left and right neighbors. It doesn't matter if the indices are valid or invalid, because every time we you will be popping out elements from the heap, and those elements will basically have a proper index. So we do have a check there. You don't need to maintain proper indexing checks in set. So for 1, 0, and 2 will be the neighbor. So you push it like this. For the next time, what you do is pop 2 for 2 comma 0. You first check if 0 is in visited hash map or not. In this case, it is already visited. Then you don't do anything. You don't add 2 here in the scores. So initially score is 1, and this is over, this is over, and the next index will be 2 comma 5, and this for this index 5 is not present in our hash map or hash set, so this will get popped out. We will add the value 2 here, and in unordered set, or else like we can call it visited, you add 5 and add the neighbors as well, that is 4 and 6. Then in the next step you pop out 3 comma 2, and now second index is already present, so you don't do anything in the scores. um, so for the next time this index will get popped. Index number 1 is also present already in the visited hash set. You don't do anything. And for 5 comma 4, 4 is not present in the visited hash set, so you include it now, and also add 5 to your scores. Now your minimum heap is empty, which means all of the indices, all of the elements are visited now, and that means the value stored in score currently after all the iterations should be your answer. And that's how the implementation goes. I have done the implementation here, which says what I actually said. So what you do is you create an unordered set, aka hash set, and you create a priority queue. In C++, you can use priority queue, that to min heap. So I've declared a function for min heap as well. So this is how it goes. If the first value, so in min heap, what we are going to store is the value and the index. So we will be comparing the values first. If there is a conflict between the values, which is like both the values are same, then you do the comparison over indices, and you know set up your priority queue. If there is no conflict, then you can simply compare the first elements itself and make the decisions. Okay, and we do the iteration over the array now. We At the same time, what we do is we push those elements along with their indices in the priority queue, and we do a simple traversal over the priority queue. And every time we pop the element, what we do is we check if that index is marked, basically if that index is present or not. So here, the step that I've used here is I'm counting if we are able to find that index in the marked um, array, or you may call it marked and ordered set. And if it's not present in the unordered set, then you mark that index along with their neighbors and add score to it. You do the same operation again and again until your priority queue becomes empty and you return the scores. And that's pretty much it. So I got an accepted solution for this. So yeah, this question is actually straightforward. Like the hint that they have already shown us is every time you will have to find the smallest index. The additional check is the smallest unmarked index. For unmarked index, we use this data structure hash set, and we were able to achieve the result that we want to. So for someone who might not be very well versed with priority queues, this function might be a little confusing, because in usual C++ sorting functions, what you do is if you want to arrange your element in ascending order, then it should be a dot second less than b dot second, but in priority queue it works exactly the opposite. That's why I've written it this way for both index as well as the value. Yeah, that's what I wanted to point out. Apart from that, I think uh, the solution is straightforward. So yeah, thanks for watching. Bye bye.